Alrighty. So welcome to the afternoon workshop. This one's going to be on JavaScript. So this morning, we went through a bunch of theoretical stuff about JavaScript, like syntax, how to use a lot of the various tools that you have. And now what we're going to do is we're going to do a hands-on practical usage of JavaScript. So we're going to get our hands dirty this afternoon. And just as a super quick recap, to solidify some understanding of how everything fits together, I'm just going to tell you how I think about JavaScript's role in a website. So if you think of your website as a human body, HTML, like Tommy said, that's like the bones, right? It provides structure to your website. It kind of says where everything is organized. And then you have your CSS, which is a skin to wrap everything together and package it neatly and present it in a nice way to the outside world. So your HTML is your bones, your structure. The CSS is what you present to everyone. It packages it all up nicely and makes it look good. But the JavaScript is the organs, it's the muscles, it's everything that makes the HTML and the CSS work together in a way that's going to allow your website to do a lot of cool things. So that JavaScript, the muscles, the bones, the functionality, that's the stuff we're going to be working on this afternoon. And so our goal is to build something from scratch. So from start to end, we're going to build something and we're going to use just JavaScript, solely JavaScript. And, you know, some of you guys might have joined WebLab to learn how to make a super cool or super nice looking website like Facebook or something, or Tinder for some of you. But when I joined WebLab, I joined because I wanted to learn how to make games. So we're going to build Snake, which is a game that used to be popular back in the day. Now, maybe not as much, but I'm sure some of you have heard of it before. And to show you what that's like, let's do a quick demo. So here I have a JavaScript app for Snake. You can see there's this little green snake and he's running around and he's trying to eat these red apples, right? So Snake, he can turn left, he can go down. But the rule of the game is if the snake runs into the border, the game's gonna end and it's gonna say game over. Your score is 9, we can play again. Another way the snake can die is if it runs into itself, right? So if we run into ourselves, we're going to die as well. So this is just the end product that we're going to build today. But let me show you some cool things that we can do here. So if I want to make the game go faster, let's make it go really fast. I can do that. So now you can see this snake is zooming across the board. And the way the way the game really works is every like threshold amount of time, it's going to update the state of the game. It's going to calculate where the snake's body parts are, where the apple is. It's going to draw all of those on this board. And then it's going to check for conditions like if the snake is hitting a border piece, if the snake is touching itself, if the snake is eating the apple, etc. So this is what we're going to build. We're going to build it all in JavaScript. It's going to be a lot of coding. So get ready. We're going to have steps, like different branches, kind of like for the HTML and CSS workshop yesterday. So if you do get stuck, definitely don't worry about that. You will have a chance to catch up. We'll be trying to use the breakout rooms as well so that you guys can try to implement things on your own. But for the start, you're just going to follow along and try to code along with me as we implement the steps of the game in the beginning. So that's what we're going to build. Let's go back to the slideshow. So the first step in building this game is let's think about the things that we need in order to make the Snake game successful. So the first is the game setup. We're going to need a board. We're going to need to have colors for the snake, all of that stuff. That's all provided in the starter code for you guys. So you don't need to worry about that. just remember at a high level, what's happening is every set amount of time, we're updating where the snake is using JavaScript logic. We're updating whether the snake has died using JavaScript logic again, and then we're drawing everything using JavaScript. Okay, another thing we need is the snake. So we need the snake to move around. We need the snake to be represented by something in JavaScript. We're going to need the snake to respond to keyboard inputs. So if you remember from the lecture this morning, there was a window dot on event listener, add event listener, something like that. So we need it to respond to keyboard inputs. We need a food object to exist and respawn at random points. We need the snake to be able to eat the food. And then we need to check if the snake is in a terminal condition. So if the snake has gone off the board or if it's ran into itself. Okay, so let's get started. What we're going to do is first you need to open up your command line. You're going to need to cd into your Catbook React folder. We're using the Catbook React folder here to code up the snake game. It's not a version of Catbook React, but we're just going to use the same folder to reduce confusion. So you're going to need to run a git fetch, a git reset -- hard, and a git checkout w1 - starter. So everyone go ahead and go to your terminal and do this. I'll do it as well. So I'm in my terminal. I've cd'd into my Catbook React folder, right? If I type pwd, it says I'm in Catbook React. So git fetch, git reset hard. Okay, so I'll give everyone a second to go ahead and do that. Some of you might have mentioned that the window organization on your screen was hard to do because you don't have as much screen real estate. I would recommend having VS Code on the left here, terminal down here, and then your Zoom and your Google Chrome window can be on the right side. All right, so hopefully everyone should have been able to do that with no problems. I'm just going to go ahead and walk through the starter code that we have to see what's up. So in this index.html file that you should have in your VS Code. Okay, first of all, open up VS Code and make sure that your file that you have open, the folder that you have open is your Catbook React folder. That's really important. But once you've opened up VS Code, take a look at this index.html file. There's not much interesting stuff going on here. This is the bones, right? This is the structure of the website. The main thing that you need to see is that there's in the body, there's a div with ID game dashboard. So that's the game board that we're going to be interacting with. So remember, there's a div with ID game board that corresponds to this big black grid right here. Styles.css, this just has the style elements for all of the things that we're going to draw. So it has some colors. You don't need to worry about it either. We're going to be working mostly with this game.js file here. This is a JavaScript file. So this controls all of the logic of the game. Okay, so what I want you all to do is open up Google Chrome, and I want you to just take your index.html and drag it over into your Google Chrome window. And it will open up the snake game in a new tab. It should look something like this. So like before, this black square right here, that's going to be the div that corresponds to the game board. Remember, divs are just boxes, right? So this is a big box. That's the game board. If we right click and click inspect, we can see that this game board here, let me make this bigger. You can see that the game board is this black square. It's a 21 by 21 grid. So that's what our snake game is going to be played on. It's this 21 by 21 grid in the center. And what's happening at a high level is every time we update the state of the game, we're going to move the snake one unit in whatever direction it's going. And we're just going to redraw it, right, and check if anything has changed. So let's first code up the logic for that. Let's think about how the snake is going to update. And to do that, we're going to open up game.js and we're going to see what's going on here. Okay. So we have this main function. That's sort of like the master loop that's running over and over again. So what's going on here? Inside main, what we're doing is we're taking the current time as an input value. And we're running this window.request animation frame on main being this function. So what this is it's basically a recursive loop. Every time we run main, we're going to queue up another call to main to run it again. So main is this process that's constantly running over and over and over again. And window.request animation frame is going to run the function main and pass in the current time. So main is going to take an argument current time. We'll worry about that later. Another thing main does is it runs update and it runs draw. So if you remember, I talked briefly about how the game worked at a high level. Every time we run this loop, it's going to update the state of the game and it's going to draw whatever corresponds to that new state. It's going to re-render our app to have the snake at the new location, have the apple at the new location if necessary. And then the update and draw functions are down here. Okay, so that's what we have so far. What I want you guys to do is I want you guys to move to your console here in your Chrome window. And then what we're going to do in our game is we're going to go inside this update function. And we're just going to type console.log rendering or updating or just something. Console.log rendering will work. Okay. And then we're going to save our file and go back to our Chrome window and refresh. And you should see in your console that this rendering word is being logged a lot. It's being logged a few hundred times every second, maybe 100 times a second, maybe a bit less, maybe a bit more. So that's how often this game is updating. So this main function, remember, that's the master for loop that's being run over and over and over again. It's going to call update each time, which is going to log into the console rendering. So that means that the main function is being run over and over again once every time this number goes up. So it's being run hundreds of times per second, right? If you kind of imagine a snake game where the snake is being updated hundreds of times per second, that would be unplayable, right? The snake would just fly off the screen, which would be no good. So what we need to do in this very first step is we need to make a threshold amount of time. We need to control the speed at which the game is updating. So let's think about how that would work. Intuitively, that would be something like if the amount of seconds since our last render is, let's say we want to update the state of the game once every fifth of a second or 5 times a second. I claim that this is going to do that. So let's think about why that's true. So this is saying if it's been less than 1/5 of a second since the last time we rendered, then we're just going to return. And return, if you recall from Python, what that does is it just ends the function right there. So it's not going to update and it's not going to draw, which is great, right? Now we're only updating and drawing if the seconds since our last render has been more than a 1/5 of a second. So we're only updating and drawing 5 times a second. Okay, but then how do we calculate seconds since our last render? Well, in order to do that, we need to have a last render time, and we're going to compare it to this current time, right? So let's let our last render time start at 0. And then we're going to let seconds, we can make this a const actually. So const seconds since last render equals the current time minus the last render time. And then one small note here is that current time and last render time are just defined in milliseconds because that's how the window.request animation frame is going to work. So we just need to divide this by 1,000 in order to make sure that this is in seconds. So try to follow along in your own VS Code if you can. And finally, what we need to do is we need to update the last render time, right? So if we are rendering, if we made it past this checkpoint, we need to let our last render time equal the current time. And now if we go back to our browser and we refresh, before rendering is counting up 100 times a second-ish. If we refresh, now rendering should only be counting up 5 times a second. So it's going up a lot slower. I don't know if you guys can see this on my share screen, but you should be able to see it for yourselves. So in this sense, we can kind of control the speed of the game. We can control how fast it's updating, right? If we wanted it to update just 1 time per second, we could change this to a 1. And when we refresh, now it's only going to update once every second. So this number is going to count up once per second. If we wanted it to update faster, if we wanted it to do 20 times per second, we can make that 20. And then it would be updating 20 times per second. So this is just a quick example of how you can use JavaScript to do things functionally for your website. We can have this website, which is a game, update once per second, 5 times per second, 20 times per second, etc. And now one last thing, for good coding practices, we don't want this number to just be 20, because 20 is pretty arbitrary. We want to call it a variable name. So let's assign it variable name snake speed, right? So we know how fast the snake is moving, and we can just define that to be 5 times per second. So we're going to want our game to update 5 times per second. That'll be a reasonable speed for this snake game. Awesome. Congrats, guys. We just made it through the first step. So you should have a website that displays a black box that's going to eventually be the grid the snake runs on. And it should render, it should update and draw 5 times per second. That's pretty good, right? That's a lot of progress. So for those of you who got lost, don't worry, we can now all catch up together. And the way we're going to do that is we're going to go to our terminal. We're going to type git reset -- hard. That's going to override all of the changes we just made. And now we're going to do git checkout w1 - step. I think it was step 1. Let's try that. Yep, step 1. And now if we go back to our VS Code, we'll see we just have everything again, because there's a version, there's a branch of this repository that has the code from step 1, the completed step 1 code. Sweet. So far, so good, I think. All right, let's move on. So this next step, we see we have this new file here that popped up, a snake.js. So let's open that. And in this file, we're going to code up all of the logic that corresponds to the snake. So maybe the first thing that we can do is we can move snake speed from game.js into snake.js, because that's something that is more relevant to the snake than it is to the game itself. And let's think, what else does the snake need to have? Well, it needs to have a body, right? There's a body that the snake has. And the way we're going to represent that is going to be a list of coordinates for the snake body. So, and each coordinate is going to be an object with an X value and a Y value. So let's have the snake just start in the middle of the grid at 11, 11. And let's give it a little bit of depth as well, so that it has a length we can kind of see where it's going. So let's have it start in the middle of the grid at 11, 11 and have some trailing parts at 11, 10 and 11, 9. So just to reiterate, we're going to represent the snake body by a list of objects. Each object is going to be like a segment of that snake. And it's going to have an X coordinate and a Y coordinate. All right, so what are we going to do with the snake? Why do we have the snake file? Well, the reason is so that we can have some, we can kind of modularize our code and have some functionalities in here. So let's define a function that updates the snake. And that's going to be a function that's going to be called every single time we update the state of the game. And then similarly for draw. So we're going to have a function called draw snake. That's going to be called every time we update the state of the game as well. And just to show you how that's going to work, every time we call update, every time this loop makes it past the threshold and calls update, what it's going to do is it's going to call update snake, right? Because we need to update the snake every single time we update the game. And then we're also going to have to draw it on the board. So that's back in your game.js file. If you go to update, your update function, just type, make sure we're calling update snake from the snake function, and we're calling draw snake as well from the snake function. Cool. Now let's think about the logic for how that's going to work. So first, first, let's think about how our snake is going to update. So what happens when the snake updates? The way I like to think about it is the head is going to move in a direction corresponding to the snake's current direction. And the rest of the body is just going to move into the position of the body part that was before it, right? So let's code up that second part first. In order to move every segment into the position of the body part before it, we're going to use a for loop, right? Because we're kind of looping through each part of the snake, each segment of the snake, and we're going to assign it to the value of the body part before it. So I'm going to explain the indexing that I'm using here in a second, but just try to follow along. So for I equals snake body dot length minus 2, I is greater than or equal to 0, I minus minus. I minus minus is, you can kind of think of it as we're just decrementing I by 1. It's the opposite of I plus plus each time. So we're going to start at snake body dot length minus 2, and then we're going to keep subtracting 1 from I until it's equal to, while it's greater than or equal to 0, we're going to keep subtracting 1 from it. And what we're going to do is we're going to assign the snake body part that at the I plus 1th index to the snake body part at the ith index. So that's going to be confusing for sure. So let's explain what's going on here. At the index snake body dot length minus 2, that's going to be the second to last element of the snake. Okay, so this here is the second to last element of the snake. So that would be this guy. And we're assigning the I plus 1th element, so the last element, to that value. And remember here, this dot, dot, dot with the brackets around it, that's going to create a shallow copy of our object. We're going to need to create copies. Otherwise, everything's going to eventually be assigned to the same object, which is not ideal. So we need to make copies each time. So what we're doing is we're starting at the second to last element. We're assigning its value into the last element. And then we're subtracting 1 from I, moving down to the third to last element, assigning its value into the second to last element, et cetera, until we reach the first element of the list, or when I equals 0, right? We're going to assign its value to the second element of the list, and then I is going to go below 0, so we're going to stop. So we just successfully shifted all of the elements of the snake down by 1, which is awesome. And now we need to move the head, right? We moved everything except for the head. Now we need to move the head. So the head is going to be the segment at the 0th index of the snake body. And how are we going to move it? Well, we're just going to have to move its x value and move its y value. And let's just have it start off by moving a positive 1 value in the y direction, just arbitrarily. Let's just have it start off like that. So let's think about what our update snake function is doing as a whole. It's looping through our snake body. It's shifting every element by 1. And then when we get to the head, we need to make it into this new, we need to move it into a new location corresponding to whatever direction the snake's moving. So we're just going to say, yep, our snake's always moving with positive 1 in the y direction. So let's just always, for now, right, we'll change that later. But for now, let's just have it move at positive 1 in the y direction. Remember, if you get stuck, if you need help, you can always jump into a breakout room and ask for help from staff there. And remember, like at the start, we're going to be doing a lot of coding together, but towards the end, as you get more and more comfortable with JavaScript, we'll have sections where you can try stuff yourself. Okay, so that should be the update snake function. Let's talk about how we're going to draw our snake. So the way we're going to draw our snake is we're going to create a div for each segment of the snake and then render that on the screen. So we're going to need to use a for loop, right? So for each element in the snake, for each element of the snake, we're going to define that segment to be the object corresponding to that element. So we're looping through the snake array, and we're going to look at the segment corresponding to that index, and we're going to draw it. How are we going to draw it? Well, first, we're going to need to make a div for that element. So if you remember from the JavaScript lecture this morning, we can do a document dot create element. We're just going to make it a div. So now we have a div that corresponds to that section of the snake. That's one of those little green squares that we had in the demo. And now let's modify our snake element. The specifics of the syntax and all this stuff, you don't really have to worry about it. Just make sure you understand what's going on at a high level. So conceptually, what are we doing? So we're setting its row to the X value, setting its column to the Y value. And then we're also going to give it the ID, the class name, snake, so that it inherits the snake CSS in the styles.css file. So if we look here real quick, we see there's some CSS to make anything that has the snake class name lime colored. So that's what's going to make it lime. So we need to give it the snake label. List, not last, sorry. All right, so we've done a for loop for each element of our snake. We've created a snake element, a div that has that corresponds to that segment, but now we need to draw it, right? And so if we remember at the very beginning when we were walking through the index.html, there was an element called game board, right? There's an div with ID game board. So what we're going to need to do is put this div that we have as a child of the game board. So draw snake is going to actually take in that game board div as a parameter, and it's going to append this div as a child. It's going to append the snake element as a child of that div. Again, this is all like not anything that you really need to know the ins and outs of for your website. So if you're a little bit confused by this exact stuff here, don't worry about that. Just understand that logically what we're doing is we're looping through our snake. We're creating a div for each segment, and we're appending that div into our game board so that it can render. Give some time for questions. So let's repeat what each line is doing. This is looping through the snake. We're saying that the segment is, we're just naming basically the ith value of the snake body, the segment. We're creating a div for that segment, right? We're going to call that div snake element. we're going to let its X position, the row start, be the X position of the segment. We're going to let its column position be the Y position of that segment. We're naming it the snake class so that it inherits the CSS from here. So it's going to be colored lime. And then we're appending it onto the game board as a child element so that it can render on the screen. Game board has not been defined yet. We're going to do that next. So game board is just going to be a parameter that drawSnake takes in so that we can access it, but we need to define game board somewhere where we call drawSnake. And let's think about it. Well, where do we call drawSnake? We call it in game.js. So in game.js, we need to define game board. That's going to be a document.getElementById. So remember document.getElementById. It looks through the index.html for a div that has the ID game board. And it takes that div and it's going to assign it to this variable in JavaScript, game board. And so now we can pass that into our drawSnake function. All right. I'm not sure how far people are. So can we get like thumbs ups, reactions or something if people have made it to this step? Okay, I see a couple. We'll give people a bit more time to catch up. All right, this next part is going to be pretty magical. So let's go. For those of you who've caught up to this step, if you go to your console, or sorry, your browser, and you refresh, you should start to see some stuff happening. All right, let's move on. So hopefully everyone's caught up. So just to recap, we have a game that updates 5 times per second as determined by the snake speed. Every time we want to update the game, so every time we reach that threshold amount of time, we're going to call update, which updates the snake and then draws the snake using the game board. And update snake is just shifting the elements of the snake by 1, and it's moving the head. And then draw snake is creating a new div for each segment of the snake and then drawing it on the game board. And so if we go back and refresh, we can see that there's a few things that are happening here. Some are good, some are bad. Let's go over the good first. So the good thing that's happening is we have some green squares that are showing up, which is great. We love that. One bad thing, what's a bad thing that someone sees? Maybe just type it in the Zoom chat or unmute if you want. What's something bad here? Yes, the snake is very long. There's a vapor trail. That's a good way of putting it, right? So what's happening here is that the snake is leaving behind all of the squares that we drew before. So it turns out that our draw snake function is a little bit wrong. It's drawing the things, but it's never erasing them, right? So every single time we're rendering the snake, we're drawing the new snake, but the old snake is not being erased. So that's an easy fix. The way we're going to do that is every single time we draw, we're first going to wipe the slate of the entire game. So the way we do that is we can access our game board div, right? So game board is the div that represents this whole black box, and we can set its entire inner HTML to an empty string. And what that's going to do is it's going to wipe away all of the child elements that we drew before. It's going to wipe everything to black, and then the new snake is going to render. So if we do that, we save and refresh. Now we have a happy little green snake that's rolling off to the right. So good thing there. What else is wrong? What else is wrong about this game? Can't control the snake. Good. We're going to do that next. The game doesn't end. It's good. We're going to do that. Out of bounds. Yeah, snake is going to who knows where. We still need food. That's right. Sydney. Yes. So the snake, if you remember, we set its velocity to 0 in the X direction and 1 in the Y direction, which intuitively would make it go like vertically upwards. But instead we see the snake is zoom in to the right, which is not ideal. The reason for this is because the way I set up the index.html and the style CSS, it turns out that this direction to the right is the positive Y direction. And that's a little bit confusing. So anyone have any ideas of how we can fix that real quick? Yeah, we can just flip X and Y, right? So if we go here and we set the row to the Y value as opposed to the X value, and we set the column to the X value as opposed to the Y value, and then we save and we go back. Now the snake's moving vertically, at least, but it's moving down now. And that's just going to be the way I'm going to fix that is I'm just going to remember in my head, okay, down, positive Y means down, negative Y means up. So when we go and do our keyboard inputs, we're going to have to remember that when we press the up arrow, we need to set Y to -1. When we press the down arrow, we need to set the Y velocity to +1. But yeah, we have a snake, it's moving. That's great. So if you got lost, you want to catch up to this step, go to your terminal or your command line, type git reset -- hard, and git checkout workshop 1 or W1-step2. And now everyone will be on the same page. All right. So after everyone's typed git reset -- hard, git checkout workshop 1 or W1-step2, everyone should be caught up to the same points. And in this step, we're going to work on the inputs. So we're going to add event listeners that will listen for keyboard input, and it will be able to control the snake. So let's do that. Let's open input.js. All right, let's start by letting our input direction be 0 in the y direction and +1, or sorry, 0 in the x direction and +1 in the y direction. And then we're going to write a function that gives us the input direction, so that instead of naively moving 0 in the x direction and 1 in the y direction every time, we can instead return the input direction whenever we call this function, so that in snake.js, when we want to figure out what direction we're going, we can just call this and get the direction that we're moving at the current time. All right, and now for the meat of this step, we need to include a way to listen for keyboard input. So window, if you remember, controls the whole screen of our page. So if we add an event listener to that, and specifically we listen for the key down events, we can take that and apply a callback function to that event. So you don't need to know that this stuff exists. You just need to know what's going on. What we're doing is we're listening for a keyboard event when a key is pressed, and then we're going to run this callback function, which takes in a parameter called event. That's going to be an event associated with what key we pressed. All right, and what's the logic here? What do we want this function to do? Well, we just wanted to check if the key pressed was one of the arrow keys, and if so, we want to change the snake's direction to that respective arrow keys direction, right? So now we just need to write this big if-else statement. So if the event's key was the arrow down key, or let's start with up. So if the event key was the arrow up key, what we're going to do is we're going to set our input direction equal to x moving 0, and we're going to set y equal to -1, right? Because we want it to go up. That's pretty straightforward, but that's not the only thing we care about. Otherwise, so else if the event key was the down key, so if the arrow that we pressed was the down key, then we want to set the input direction to y +1, x 0. And just remember here, X and Y were swapped before, and the way we fixed that was by assigning the row to Y and the column to X. But we did not fix the Y value being plus or minus 1. So that's why we have to do that jank thing here.
And arrow down, array down.
My bad, not array down, arrow down. Thank you. And then we can do the same for right and arrow left. So let me just code that up real quick. And then, you know, definitely, if you're lost, ask for help. There's a help view. This is not supposed to be like super easy from the start. That's why we have a whole workshop devoted to it. Ask for help. Ask questions. And once you've gotten to this step, we need to do one more thing, but make sure you catch up here. Just try to follow along. Are people done with this step? Can I get like thumbs ups if people are done? It's like 5 people at the top of the Zoom are saying yes, and then everyone else is just absolutely silent. This is great.
I saw about 40 thumbs up on the participants thing.
Oh, sick. That's pretty good. 40 is more than 5. So as a reminder, what we're doing in this step is we're basically, instead of just defaulting our snake to moving in 0 in the X direction and 1 in the Y direction, we are adding a way for us to interact with the keyboard with this window add event listener. And we're just checking if the key was an up arrow, we're going to set the snake direction to go up. If it was a down arrow, we're going to set it to go down. If it was a right arrow, we're going to set it to go right. And then left is left. And so now that we have our input direction, if we go back to our snake.js, instead of naively updating it by 0 and 1, instead we let snake direction equal get direction, right? So we call the function in order to retrieve our input direction. Then we can update our snake by the X velocity of that snake's direction and update the Y by the Y velocity. And for those of you who made it this far, once you do this, you can go to your browser and refresh, and you should be able to control the snake and move it around the board. And you might see some weird behavior, but that's stuff we're going to fix later. All right, let's demo what's going on here. So we have the snake, it's moving around. I can press my arrow keys and make it move wherever, which is pretty cool. Does anyone have Any concerns though about how the snake is moving? What's wrong right now, as of now? Yep. So it can fly off the grid still, and it'll loop around because of how some array indexing logic works, but we can fix that later. Another thing that's bad is that if I'm going right, I don't want my snake to be able to do a 180-degree and turn left, right? See how it kind of runs into itself when it turns around? In a real game of Snake, that's not going to be possible. You should only be allowed to make 90-degree turns. So we actually need to code that up. We don't want our players, our users, to be able to make a 180-degree turn. All right, so let's think about how we're going to do that. So if we go back to input.js here, we need a way to make sure that the snake's last input direction is not going to be 180 degrees from its current input direction, or from the new arrow that we press. So in other words, if we're moving up right now, we should ignore any up or down arrows. Up or down arrows should not do anything if we're moving up. Only left or right arrows should do anything. And if you just think about that logically, that should kind of tell you how you're going to code it, right? So if the arrow key that we press would make it move in an input direction that is parallel to its previous input direction, ignore it. Well, in order to code that, we need to have a variable that corresponds to the previous input direction, right? So we need a previous input direction to compare it to. So let's define that variable. So I'll call it last input direction. So let's let our last input direction equal, it's also going to be 0 and 1 to start. Right. And then to update our last input direction, we just need to check whenever the snake gets the input direction. So whenever the snake asks us, hey, what's the input direction? We're going to say, hey, this is the input direction. And then we're going to set our last input direction equal to the current input direction. Okay, so now we have our last input direction to compare to. Now we just need to make sure that when the arrow key is up, as long as it was not the case that we were moving up or down, so as long as it was not the case that we were moving up or down, or it was the case that we were moving side to side, right? So as long as it was the case that we were moving side to side before, we're good. Otherwise, we should ignore that and not do anything. So that's pretty, that should be pretty straightforward to code. We just need to add an and condition to our if statement. So if the event key that we just pressed was an up arrow and before our X input was +1 or -1, so it was moving side to side, then we can set the input direction to go up. Otherwise, we should ignore it. So if our last input direction's X value was not equal to 0, then we should allow it. Otherwise, if it was equal to 0 before, so if the X direction was 0, that means that we were already moving up or down, which means we should ignore this input. All right, hopefully that makes sense. Give it a while to sink in. Some of you might have gone ahead and done what I'm about to do already, but we're just going to include the same logic for the other directions. So for up, for arrow down here, it's going to be the same. If the previous direction's x value was not 0, we're good. We can go ahead and change it to move down. For the horizontal directions, right and left, we need to check that the previous y value was not 0, not the x value. And now if we go back and refresh, we can see that our snake cannot run into itself anymore. So if I'm going down, even if I press the up or the down arrows, it's not going to be able to run back into itself, which is pretty awesome. So we're not going to have a degenerate snake anymore. It's always going to be running around, but there's still a few things we need to add, right? So we still need to add food. We still need to add a check to make sure that the snake does not die, or if the snake died. So let's do that. So for the next step, we're going to do get reset -- hard again. That's going to get rid of all of our changes. And then we're going to check out to step 3. And that's going to give everything back that we just had. Now we have this new file called food.js. And food.js is going to be the file that represents all the logic for the food. So now I think it would be good to draw an analogy between the food and the snake. They're kind of similar, right? There's a lot of parallels between the two. They're both boxes that show up on the grid, and they both need to check like if they're touching other stuff, etc. They both need to have logic that updates them. So let's say that you had to code this food.js file and you already had the snake.js file. Well, maybe it's a good thing to reference your snake.js file to see what things you had there, and then just have a corresponding version for your food. So I think now is a good time to use the breakout rooms. So just join a random breakout room and then try to create a food file that has a position for the food, some pseudocode. It doesn't have to be real code, just pseudocode that updates the food, right? So some logic, some things that you would need to check for every time you're rendering to add the food, for what to do with the food. And then as well as a draw function for the food that should look very similar to the draw function for the snake. All right. So why don't you guys go ahead, join the breakout rooms, try to work on this for 10, 15
Hey,
minutes.
as an interjection, basically, if you guys check Piazza or email, we sent out a breakout room form. So either if you signed up, join the one you signed up for, else join one of the ones that people didn't sign up for. And if you need help, just insert yourself on weblab.2/q.
Yeah, what Claire said. So, you can click the breakout room button at the bottom of your Zoom and just join a room. It doesn't matter which one you join, or you can stay here and work here. But if you want to work with your friends, or if you want us to come help you, definitely use the breakout rooms for that. All right, I think it's been a good amount of time. Let's. All right, I think it's been a good amount of time. Let's all try to get back and see what's up here. So I asked you guys to go and implement food.js with the hint that it was very similar to snake.js. I was hoping that you would just kind of pattern match and do what you did before. It turns out that pattern matching is like, it's basically all that JavaScript is. You just try to find something similar to what you're trying to do and then copy it. So first thing that we're going to need to do is let's go to our food.js, and I'm literally just going to copy my snake function or snake file and just paste it into my food file, my food.js. All right, and now I'm going to change some stuff. So instead of a snake body, we just want to have a single food object. Let's get rid of all of that junk. Right, we just want to have a single food object. We can have it start, I guess it's bad if it starts in directly in the middle, right? Because then it would start on top of the snake, which might get a little bit confusing. So what I'm going to do instead is I'm going to have it start at, say, 518, something like that. Seems pretty reasonable. All right, have my food. One thing that I'm going to do that you guys probably didn't do, and it's totally fine, is I'm going to have an expansion rate. That's just how much longer the snake is going to get every single time it eats a piece of food. We can just have that be 1. For update, instead of update snake, this should be update food. And then what I'm going to do here. So what needs to happen for update food? Well, actually nothing for the most part. Usually nothing's going to happen for update food. The food is going to stay exactly where it is as long as the snake is not touching it. But if the snake is touching it, so if the snake is eating the food, let's just function on snake. So if the snake's body is overlapping with where the food is, then what I want to do is I want to update the food by moving it to a new position. So we want to move the food position, and we want to increase the length of the. Okay, so that's what update food's going to look like. And for draw food, instead of a for loop, there's not like a whole bunch of food pieces. There's just one. So we can get rid of this for loop. And basically, I'm going to leave this code down here. I'm just going to code up what the draw food version of it would be. So let's have a const food element. Not get element, create element. It's going to be a div, right? We're going to represent our food object by a div. We're going to locate it. We're going to give it a grid row start corresponding to the food's y value. We're going to give it a grid column start corresponding to the food's x value. We're going to name it food so that it can inherit the CSS from our CSS file, the food label, so that it can be read. And then the last thing that we need to do is append it to the game board. So it's literally the exact same as the snake element. except now it's the food, right? We just translated everything over. So that should be it for draw food. Now we need to think about how we're going to update the food. Actually, let's first make sure that draw food works. So let me comment out my update food. Let's have it do nothing. And then here in our game, we're going to update the food every time we update, as well as draw the food every time we update. All right, let's see what happens. All right, so there's a piece of food that we've drawn on the game board, right? So all we did there was we just copied the exact same code that we used in JavaScript for draw snake, and we instead repurposed it for drawing the food. But we'll see that when our snake runs into the piece of food, nothing happens. And the reason is because our update food function is not doing anything yet. So in this next part, we're going to code update food together. Okay. And like I said before, what does update food need to do? It needs to check if the snake is overlapping with the food piece. And if it is, we're going to increase the length of the snake by 1. And we're also going to move the food position. Let's punt on this move the food to a new place for now. Let's just do that with hard code. So let's just set it to like 19.5 or something. Okay, so when the snake eats it, the first time it's going to jump to the other side of the board. And let's focus on how we're going to increase the length of the snake. Well, how we're going to do that, that's probably going to be a function in the snake.js file because it has to deal with interacting with the snake. So we can just say, okay, let's define this function expand snake. And it's going to increase the length of the snake by the amount that the food piece should increase it. Oh, food definitely should not be const, because it's going to be moving around. Okay. And you notice here something that you might see me doing a lot is I'm punting on like doing these tasks that I set aside for myself to later. So what I'm doing is I'm saying, okay, let's just define some function on snake later that I'm going to code and expand snake later that I'm going to code. And it turns out when you're coding JavaScript, personally, I think this is a really good way to code. It kind of allows you to keep track of the full picture and then set smaller tasks for yourself later. So you kind of want to write everything in pseudocode first, and then like clear pseudocode that really tells you what you need to do later, and then go back and do those things later. So now when I look, this makes sense, right? If the food is on the snake, we're going to expand it by the expansion rate, and we're going to set the food position to somewhere else. So all I need to do now is code a function that checks whether a piece of food is on the snake, and also code a function that will expand the snake by some set amount. So let's go to snake.js and do that together. So I'm going to scroll to the bottom, define a function on snake that takes in a position and returns a Boolean, let's just say true for now, of whether or not that position is on the snake. All right, but it's not always going to return true. We actually need to code up the logic for this. So what does that logic look like? Maybe if you took some time, you could figure it out for yourself, but I think we're just going to rush through this section together. We're going to use a for loop, right? So we're going to check for each segment. We're just going to verify, is this segment on the snake? So I'm going to define a new function called equal positions, which I'll make later. Another example of punting on work, but we're gonna say, hey, are these positions equal? The position of the segment, which is the ith element of the snake body, and the position that we were passed in, which would be the food position, right? So are these equal? So if they are equal, then the food is on the snake, right? There is a segment of the snake that has the same position as the food, so we should return true. And then if we make it through this entire for loop, we checked every segment of the snake that did not, that was on the snake, and it did not overlap with the position that we passed in, we should return false. For the more astute observers, if you remember the for each function that was briefly mentioned this morning, you could also use that as well. Maybe you can figure that out on your own sometime, but we're just going to use a for loop this time. And now we need to define this equal positions function, right? So let's define equal positions. It's going to take in a position 1 and a position 2. And it's just going to return true if the x values are the same and the y values are the same, right? So let's just say return the position 1's x value equals position 2's x value, and position 1's y value equals the position, triple equals, my bad, position 2's y value. Make sure you're using triple equals. All right, so quick summary. We just went to our snake.js file to code some functions that were relevant to our snake. The first one checks if a given position is on the snake by looping through each segment of the snake. And then the second function was just a helper function for the onSnake function. So onSnake seems to be good. The other function that we wanted was the expand snake function. That's going to be an interesting one. So expand snake is going to take in an expansion amount, right? And it's going to expand the snake by that many elements. And let's think about what expanding the snake is doing. All we're doing is we're appending elements onto the end of the snake's body. And those elements should just be copies of the last segment in the snake. So we should just pile up some elements onto the end of the snake. So for let I equals 0, I is less than amount, I plus plus. So for each value of amount, so if amount's 2, we're going to do this twice. We're just going to push, which is analogous to append in Python, right? We're going to push or append a copy of the last element of the snake body. And that should expand the snake. So to summarize what this is doing one more time, for each amount that we're going to expand by, this is going to be 1 for our purposes. So this for loop is only going to run once. But if you wanted to expand 3 times, it would loop through 3 times. And what it would do is it would add a copy of the last element onto the end of the snake's tail so that the snake grows in length. Hopefully you're seeing how JavaScript is handling all of the logic for your website at this point. It's kind of HTML and CSS are responsible for organizing and showing everything, but JavaScript is where all of the logic is being handled. And so if we all caught up here and we go back to our game board and we refresh, now when we overlap with this piece of food, boom, we got longer by 1, and it reappeared at 519 or 19.5 or wherever I had it reappear to. All right. And remember, that's because now every time we update the game, we're not just updating the snake, we're also updating the food in the same way. So we're always updating the snake and the food, and then we're drawing the snake and the food where they need to go. Some of you might have noticed an interesting occurrence at this point. So when you eat the first piece of food, and now you go hunt down the second piece, your snake is going to exhibit some strange behavior. Namely, it's just going to keep getting longer and longer and longer. And it's just this, it's the snake that's really long. And the question is why? Why is it doing this? Why is it just getting so arbitrarily long? And I'll give you a second to think about it, right? So just think about what we're doing in our JavaScript code. What's the logic that we're executing? And if we read through this a couple of times, we'll see that in our update food function, the condition is if the snake is on the food, it's going to expand the snake, and the food is going to go to this position, 19.5. And so since when the snake passed through 19.5, it was on 19.5, it ate the food, it got longer, and then the food got put on 19.5 again, and it ate the food again, and it got longer again. So it's always perpetually eating the same piece of food that is on the snake's body. That's no good, right? So luckily, this is a pretty easy problem to fix. Instead of hard coding the food to always appear at this location that's on the snake, we're going to have the food appear at a random position that is not on the snake. All right, so we're going to get rid of this hard-coded junk, and we're going to replace it with a function that we're going to define later that's going to give us a random food position that is not on the snake. All right, so hopefully everyone is up to date here, up to this step. If not, no worries, we just hit a checkpoint. So let's get reset -- hard and get checkout w1 - step 4. Everyone should do this, even if you are caught up, because there's some things going on in the background that we're skipping over that will cause your code to fail if you don't do this. We're just focusing on the JavaScript for now. Alrighty, so once everyone's done that, get reset -- hard and get checkout w1 - step 4. We're on step 4 now. We should see that we've defined this get random food position down here, and it's returning 15,5, which is not good. We want it to actually return a random food position. So let's think about that. How is that logic going to work? What we need to do is, let's think about it in pseudocode. What we're going to do is generate a new random position grid, and then while that position is on the snake, we need to regenerate until we get a position that's not on the snake. Okay, so while the position is on the snake, we're going to re-roll until we get something that's not on the snake, and then we're going to return that position. Okay. So let's do that. We're going to define a function later called random grid position, which gives us a random grid position. Okay, so let's say let our new food position equal random grid position, while new food position is while the new food position is on the snake, which luckily we have a function that does that already, right? We have a function that checks if a position is on the snake. So we can just reuse that here. So while this new food position that we generated is on the snake, we're going to try again. So we're going to set it to a new random grid position. And this while loop is going to keep running until new food position gets set to a random grid position that's not on the snake. And we can return that as our answer. I'll give you guys a second to follow along. The important thing here is just really driving in this point that JavaScript is what's handling all of the logic for updating our website state. So whenever we want our website to do something, we want to use JavaScript to do that. So this is saying, we're going to try to guess a random position on the grid. If it's on the snake, we're going to guess again. And while it's on the snake, we're going to have to keep guessing again until we get something that's not on the snake. And only then can we return it. Okay, and now we can go to this new file that we've created called grid.js, because random grid position is something that should be defined in the grid.js file, right? It's related to the grid. So let's do that. First, we need to let it know that the grid size is 21. We're playing on a 21 by 21 grid. And let's now define our function, random grid position. And how is random grid position going to work? Well, this is a pretty neat trick that might be useful for some of you who are going to use random numbers in your website. We're going to want to generate a random number from 1 to 21, because that's going to be the index on the grid. Those are going to be the coordinates. So we want to generate a random number from 1 to 21 and do that twice, once for the x value and once for the y value. So how are we going to do that? The syntax for that, what we're going to do is first, we're going to generate a random number. So we use math.random. That's going to give us a random number between 0 and 1. Right? Now we're going to multiply this by the grid size. That's going to give us a random number between 0 and 21, but not quite 21, 20.99999, etc. Right? So it's going to give us a random number between 0 and 20.9999999. We're going to take the floor of that to give us a random integer between 0 and 20, and then we're going to add 1. That's going to give us a random number between 1 and 21, and we're going to do the same thing for our y value. Alrighty, let's see what happens when we refresh. So when we refresh our game, we're going to see that the food is not going to always appear in this corner. It's going to appear at a random location every time we eat it. And furthermore, that location is guaranteed to not be on the snake. So we won't have those issues of an infinitely long snake anymore, which is awesome. The key thing to notice here, I guess 2 tricks. First, we learned the trick where you can get a random number. And also we learned that you can kind of reuse functions that you've already created in JavaScript. Okay, so we have basically a functioning snake game, kind of. The only thing that we're missing, which you might have noticed, is that the snake is currently off the board. It's off the screen. It should not be allowed to do that. It should die, right? The game should terminate when that happens. And furthermore, when the snake runs into itself, it should also die. Oh, I need to go one more. Oops. There's some bugs when like the snake goes off the edge of the grid. So luckily we don't need to worry about that, because when we finish coding up the game correctly, it will not go off the edge of the grid. But yeah, right now we almost have a complete game of Snake. It's just that the snake can run into itself like so, and it can also run off the edge of the grid and do some weird stuff there. So we need to code up logic to handle that, and then our Snake game will be complete. Alrighty. So here, let's go back to our game.js, and let's notice something. So every single time if you recall back to the very beginning of the lecture, every single time we surpass this threshold of 1/5 of a second, it's going to update the position of the snake, and it's going to draw the snake. We want a way of terminating this entire function if the game is over. So to do that, let's define a game over variable and initialize it to false, right? So the game does not start as over. But then if the game is over, we don't want to call the next iteration of the main function. So if it is the case that the game is over, we don't want to do this. We just want to skip. We want to return. We want to terminate this loop. And now let's code up some logic for figuring out when the game is over. So how should we check that? Probably in our update function. Every time we update the state of the game, we should check to see, hey, is the game over? So every time we update, let's call is game over. So we can set game over equal to is game, or something like that. So basically what we did, we defined a variable for game over, initialized it to false. And now every time we update the state of the game, we're going to check, is the game over? If it's not over, game over is going to stay as false. If it is over, game over is going to be set to true. And then the next time we run main, it's going to terminate the process and not call the next window. So the game's just going to stop, which is good. All right, so how do we know if the game is over? Checking if the game is over, really there's two ways for the game to be over, right? So the first way is if the snake ran off the board. So if the snake is out of bounds. And the second way is if the snake is overlapping itself. So let's go to snake.js, and we can define game over here, I guess, is game over. What that is it's just, hey, is the snake out of bounds? Or is the snake intersecting itself? Right, so game over is true if either it's out of bounds or it's intersecting itself. All right, so far so good. Now we just need to write functions for those two cases. So let's define a function, is snake out of bounds? And how do we check if the snake is out of bounds? I claim that you can just check if the head of the snake is out of bounds, right? And the reason is because if the head of the snake is out of bounds, the snake is out of bounds. If the head of the snake never went out of bounds, well, the other segments of the snake are just they're places where the head used to be. So if the head never went out of bounds, then the snake never could have gone out of bounds at all. So we just need to check if the head is out of bounds. So let's define a function, and we can just say is out of bounds, and we can call that on the snake. Oh, just is out of bounds, and we can call that on the snake's head, which is the 0th index of the snake body. So is snake out of bounds? That's really just returning if the snake's head is out of bounds. And now let's define is out of bounds. That's probably something that's going to go well in our grid.js file. So if we head over to grid.js, const is snake out of bounds. Oh, sorry, is out of bounds, right? Is out of bounds. It takes in a position and it returns if the position's x value is less than 1, or if the position's x value is greater than the grid size, or if the position's y value is less than 1, or if the position's y value is greater than the grid size. That's how it's going to check if a position is out of bounds. Alrighty, so I think that should be good for checking if the snake is out of bounds. The last thing we need to do is to check if the snake is intersecting itself. That's going to be interesting, but we can kind of use the same logic, right? So for a snake out of bounds, we only had to check if the head was out of bounds. It turns out for checking if the snake is intersecting itself, you only have to check if the head of the snake is intersecting itself, because that's when the head kind of runs into the body. And if you kind of remember, we wrote this function up here on snake, which checks if a position overlaps with any of the other positions of the snake. So what we can just do is kind of reuse that function, right? It seems pretty similar to check if the snake's head, like imagine, oh, sorry, let's start over. Imagine if we checked on snake on the snake's head. This is almost checking if the snake's head intersects any other part of the body. Except this for loop starts at index 0, which means that it's going to check whether the snake's head is equal to itself, which is always going to be true. So this is always going to return true. We don't want that. We want something really close to that, right? So let's copy over on snake. And instead of starting at the 0th position, we're just going to start at the 1st position. And now we're going to be able to check if the snake's head overlaps with any other part of the body. So I'm saying the snake head is the 0th element of the snake body. And then starting from the 2nd element of the snake body, or the element at index 1, we're going to check to see if the snake head has the same position as that element. If it does, the snake is intersecting itself, so we return true. Otherwise, if we made it through the entire for loop, it never touched anything, then we should return false. And just like that, you should have a fully functioning version of snake. So if we refresh and we run off the edge, the game is over, right? It stopped the game. It's frozen. If we get long enough where we can run into ourselves. Oh no. All right. If we get long enough where we can run into ourselves like that, it will just stop the game. So yeah, that's kind of how you build a game of Snake using JavaScript. So it's 5 p.m. ET. So we're gonna have to let you guys go soon. But just to recap, JavaScript is the logic handling program language for your website. So whenever you want your website to respond to a click of a button, whenever you want your website to send someone a specifically formatted message, all of that logic is going to be handled through JavaScript. You can define functions to do stuff that helps you. And a lot of the syntax that we use today, you'll be using yourself. And don't worry if you don't understand it completely at the moment, because it just takes time and practice. But hopefully you got to get your hands dirty a little bit today. You learned some debugging tricks, like how we were doing a console.log on the update in the very beginning. That's going to be your friend a lot when you're coding your websites. And hopefully you just had some fun because you got to code a working game, right? A working web app. So yeah, that's the workshop. We'll see you guys tomorrow. Thanks for coming.
Yeah. Denson, you want to tell us what your VS Code color scheme is, or color palette is? A lot of people are asking.
My color palette, it's the Spacemax color palette. I think it's some, let's see, Spacemax. Maybe it was Emax? I don't know. I think it's Spacemax.
I'll type in the
Basically, here, I can link it in the daily recap that we're going to send out soon. Max. Yes.
Your age thing gives me anxiety.
If you want a complete working version of the Snake game to play for yourself, you can check out workshop W1-complete, like so. And if you do that and then go to your browser and refresh, it'll be a game of Snake that you can just like play for fun.